Good morning. In this session, we evaluate ammonia gas and dinitrogen tetroxide. Welcome. Now, ammonia gas is not a naturally occurring gas. However, it's preparable in the laboratory by use of ammonium chloride and lime water. When ammonium chloride is treated with lime water, it decomposes and forms ammonia gas and calcium chloride and then water. In this case, the laboratory method for preparation of ammonia gas is the synthesis of lime water and ammonium chloride. The reason why we are looking at this gas is that it has quite unique applications. One, it is used as a smelling salt to prevent fainting. Two, it is suitably used in the manufacture of nitrate fertilizers. And three, it is used as an hydroxide as a water softener. What are the properties of this gas? One, ammonia gas has a unique property of being highly soluble in water. Two, it is alkaline. And three, it has a unique pungent smell. Therefore, we can see that ammonia gas is colorless, it is pungent smelling, it is less dense than air, it is highly soluble in water, forming an alkaline solution, and it does not support combustion. How do we test the gas? To test the gas, we need HCl. We use HCl as a gas, and when ammonia meets HCl as a gas, it forms white fumes. We can also use HCl as an acid, and when ammonia meets HCl acid, it forms a colorless solution. So these are two distinguishing tests, and we find that ammonia is favorably confirmed present by conducting a test with HCl gas, followed with a test with hydrochloric acid. When you test it with HCl gas, we have seen that it forms white fumes, and when you test it with HCl solution, it forms a colorless product. Now, you can also do the fountain test, where ammonia is placed inside a round bottom conical flask and allowed to enter the flask at atmospheric pressure, and then it forms a fountain akin to what I may illustrate here. So you may find that there is a trough of water composed of a solution of ammonia, and in this case we expect the atmospheric pressure to be acting on the surface of that solution. Now, if this solution is mixed with an indicator like universal indicator, so we find that aqueous ammonia, the ammonia gas would be placed inside the round bottom flask, and then a solution of water treated with universal indicator so as the cork is opened, the universal indicator solution will jet into the flask, thereby emitting ammonia, and since ammonia is readily soluble, it dissolves it, and when it dissolves, it forms a partial vacuum. Now, when we open the clip a second time, due to the presence of the partial vacuum, we realize that the indicator solution will come forcefully and find a vacuum. Now, the presence of that vacuum will lead it to the formation of a fountain. So we can test ammonia gas by what is known as the fountains test. Next to this, as we have been looking at nitrogen and its compounds, we have an unstable form of oxide of nitrogen. The unstable oxide of nitrogen is dinitrogen tetraoxide. Now, this dinitrogen tetraoxide is a yellow gas. It exists in dynamic equilibrium states with nitrogen 4 oxide gas. In a nutshell, we find that while the nitrogen tetroxide is yellow, nitrogen 4 oxide is brown. Therefore, when the nitrogen tetroxide is exposed, it gradually changes color from yellow to brown, signifying that it's changing its state from the nitrogen tetroxide to the brown gas nitrogen dioxide, with the transitional temperatures being 96 degrees Celsius. When the temperatures are below 96, it is exclusively nitrogen oxide. When it's above 96 degrees Celsius, it is the nitrogen tetroxide. Now, this gas has similar properties to that of nitrogen oxide, with only difference being the color, that it is yellow, while nitrogen oxide is brown. So it is denser than air, it is insoluble in water, it's acidic, it does not support combustion, and it is unstable. How do we use it? We can use it to concentrate nitrogen oxide by simply heating it to decompose it, and then it forms the brown gas nitrogen oxide. Thank you. That has been a description of the compounds of nitrogen, including nitrogen oxide, dinitrogen tetroxide, and ammonia gas.